Hey everyone, welcome back. You know how sometimes you take a picture and think, wow, the edges in this photo are so sharp.
Yeah.
That's edge detection.
Right.
And it's something that computers use all the time to find the lines and the boundaries in images.
Yeah, it's pretty important stuff.
Yeah, it's used everywhere. Think about self-driving cars, spotting pedestrians, doctors looking for tumors in scans, even those filters we use on our phones to make our pictures look good.
Yeah, all of that.
But today we're taking edge detection to a whole new level,
Oh,
the
really?
quantum level.
Okay, cool.
Yeah, we're diving into research that explores how to do edge detection with quantum computers.
Mm,
And those work completely differently than the computers we use every day.
very different. Yeah, much different.
So we're talking about making something that's already super useful even more powerful.
Yeah, that's the hope.
I'm intrigued.
Yeah.
But before we get too far into the quantum realm, let's quickly recap the classic method,
Okay,
canny edge detection.
sound good.
Can you kind of walk us through that?
Yeah, so think of it like a four-step recipe.
Mm.
The first thing we do is smooth the image. You can think of it as like slightly blurring it.
Yeah.
And we do that to get rid of tiny details that might distract us.
Gotcha.
Then we have to calculate something called the gradient.
Gradient.
And that's basically finding where the brightness changes the most dramatically in the image.
Okay.
Those are the areas that could be edges.
So it's like highlighting, like if you were going to color in a coloring book,
Yeah, exactly.
you'd want to have the outlines.
Yeah, you need to know where to color inside the lines.
Exactly.
But those outlines might still be a bit fuzzy at this point.
Okay.
So the third step is called non-maxima suppression. It sharpens the edges.
Okay.
It's kind of like taking a fine tip marker and going over those edges,
Gotcha.
just to make them crisp and clear.
Okay. I'm starting to see the picture.
Yeah.
We got these outlines. What happens in the final step?
So the final step is called double thresholding, and that's how we separate the true edges from any noise that might be left over in the image. So imagine you have like a faint pencil sketch and you want to trace over the most important lines with a pen to make them darker.
Okay.
That's basically what we're doing here, just making sure we get all the important edges.
So we're making sure we don't miss anything.
Right.
Cool. And this canny method, has this been the gold standard for a long time?
Yeah, absolutely. It's reliable, it's efficient, and it's used everywhere.
Okay.
But there's always room for improvement, right?
Of course.
Especially with new technology like quantum computing.
Okay. Now we're getting to the good stuff.
Yeah.
How do we even start to do canny edge detection on a quantum computer? It's not like we can just swap out the processor.
Well, that's the thing.
Yeah.
Classical computers, everything happens step by step, one at a time.
Yeah.
But quantum computers, they use these things called superposition and entanglement.
Okay, hold on for a sec. These are some pretty big concepts. I want to make sure all of our listeners are with us.
Good idea.
Superposition. Think about a coin spinning in the air.
Okay.
Could be heads, could be tails.
Yeah.
At the same time.
Right.
So that's kind of like a qubit,
Yeah, that's a good way to think about it.
the quantum version of a bit.
Exactly.
And entanglement is even weirder.
Mm-hmm.
Imagine you have two of these coins spinning in the air,
Okay.
and they're linked, magically linked.
All right.
You flip one to heads, the other one instantly becomes tails, no matter how far apart they are.
Yeah, that's entanglement.
And this gives quantum computers incredible power.
A lot of power. Yeah, it's a lot.
So researchers are trying to harness this power to change how we do canny edge detection.
That's right.
Okay, but how do we do that?
Well, the key is figuring out how to do all the steps in the classical canny method, but using the language of quantum mechanics.
So it's like rewriting the recipe for a whole new kitchen with quantum ingredients.
That's a good way to put it.
What are some of the challenges to run into?
Well, for starters, you have to represent the image in a completely different way.
Okay.
In the quantum world, we use something called NEQR. It stands for Novel Enhanced Quantum Representation.
We won't go into all the details here, but it's just a completely different way to encode the image
Yeah,
using those crazy qubits that we talked about.
right.
So we've got our quantum image. How do we smooth it?
Well, we don't use a traditional Gaussian filter.
Yeah.
That would be really slow on a quantum computer.
Yeah.
So researchers came up with a new technique. It's called translation, stacking, and weighted summation.
That's a mouthful.
Yeah.
What does that even mean?
So imagine you take multiple copies of the image
Okay.
and you shift each copy just a little bit in a different direction.
Mm-hmm.
Then you stack all those copies on top of each other.
Okay.
So for any point on the image,
Yeah.
you've got this stack of values that represents the surrounding pixels.
Gotcha.
And if you average all of those values, it's the same as doing a Gaussian blur. Oh, interesting.
Yeah, but it's a lot faster for a quantum computer.
So it's like taking snapshots of the image from different angles
Yeah.
and blending them all together
Right.
to get a clearer picture.
Exactly.
Clever.
Cool, huh?
What about finding the gradients? How does that work in this quantum kitchen?
Okay, so this is where things get interesting.
Okay.
Quantum computers work best with powers of 2,
Yeah.
but gradients can be negative,
Ah.
and that's a problem.
How do you teach a computer that loves powers of 2 to deal with negative numbers?
Right, well, they use a trick called 2's complement.
2's complement.
Yeah, it's a way to represent negative numbers, but only using 1s and 0s.
Interesting.
So now the computer can do the calculation.
Oh, like a secret code?
Yeah, kind of.
So quantum computers can work with negatives.
Exactly.
Pretty ingenious.
And for each step of the Canny process, the researchers have designed specific quantum circuits,
What's a quantum circuit?
like a set of instructions.
Okay. That tell the quantum computer exactly what to do.
Okay.
How to compare values, how to do calculations,
Gotcha.
everything it needs to do edge detection.
So it's like building a quantum assembly line with each station handling its own task.
Yeah, a good analogy.
And it's all happening at the same time.
Thanks to quantum mechanics.
This is starting to feel like science fiction.
I know, it's crazy, right?
But hold on a sec.
Sure.
Before we get too carried away, I have to ask, why should anyone care about all of this?
That's a good question.
It's fascinating from a tech perspective.
Yeah.
But what's the impact going to be for the average person?
Well, that's a great question, and that's what we're going to get into in the next part of our deep dive. We'll unpack the potential benefits of this and how it could change a lot of different fields.
Okay, I'm hooked. Stay tuned, listeners, because things are about to get really exciting.
So we know that quantum canny edge detection is interesting from a technical standpoint, but as you mentioned, the real excitement is what it can do.
Absolutely. Let's get to the heart of it. We talked about how it works. Now tell me, why should people even care about this?
Imagine a world where doctors can make diagnoses much faster
Okay.
and more accurately. With quantum canny, doctors could find tumors or abnormalities in scans much earlier than we can today.
And that's huge, especially when we're talking about those diseases where catching it early is so important.
Exactly. Early detection can save lives.
Absolutely.
And it's not just for static images either. Think about analyzing video in real time.
Okay.
Self-driving cars could use quantum canny to spot pedestrians,
Yeah.
obstacles, maybe even predict accidents before they happen.
So we're not just talking about avoiding fender benders.
Right.
This is about making self-driving cars way safer for everyone.
Yeah, exactly.
That's incredible.
And you could use this for security, too. Imagine analyzing footage from tons of cameras all at the same time. Quantum canny could spot anything suspicious instantly.
Like a superpowered security guard that never misses a thing.
Basically. But it's not all about practical stuff either.
Okay.
What about creativity?
Oh, yeah.
Artists and designers could use quantum canny to make incredible new art, stuff we can't even imagine right now. Or think about virtual reality.
Oh, wow.
You could create these immersive worlds with so much detail.
So it's not just about making things more efficient.
No.
This could change how we think about art and creativity as a whole.
Exactly. And that's just the beginning. As quantum computers get more powerful, who knows what we'll be able to do with them.
It's like we're standing at the edge of this huge, uncharted territory, and we have no idea what we'll find.
That's a good way to put it. It's pretty exciting.
Yeah, it's exciting and kind of scary at the same time.
Definitely.
Does the researchers actually test this out, though?
Good question.
Or is it all still just theoretical?
Well, we don't have really powerful quantum computers just yet,
Right.
but the researchers did run simulations on a classical computer.
Okay.
They tested their quantum canny algorithm and compared it to the regular canny edge detection.
So a glimpse into the future.
Yeah, basically.
What happened? What were the results like?
It was really promising. The quantum canny had much sharper edges.
Really?
And the backgrounds were clearer, too, so it looks like it can be even better than the regular canny,
Wow.
especially in real-world situations.
That's incredible. So it's not just a cool concept. It really works.
Yeah, it really does.
Were there any problems with the simulations? Did they have to cut any corners?
Well, they did have to make some adjustments because quantum computing is still so new.
Yeah.
For example, instead of calculating the angles directly, they used tangent values.
Interesting. So they had to work around some limitations in the technology.
Exactly. But as quantum computers get better, those limitations will go away.
Yeah.
And then we'll have even more accurate and efficient quantum canny.
That's amazing to think about.
It is. And it's important to remember, this research opens up even more possibilities for future work.
Okay.
Remember, they use tangent values instead of calculating angles directly? Well, that's just one example of how we can improve things. As quantum computers become more powerful, we can come up with completely new ways to do image analysis.
Oh, wow.
Things we haven't even thought of yet.
It's crazy to think about all the potential applications.
It is.
We started by talking about blurry images, and now we're talking about revolutionizing healthcare and transportation and even art.
That's what I love about this stuff. It all starts with an idea,
Right.
and who knows where it might lead.
It's been a wild ride.
Definitely.
And I think it's really important to remember
Yeah,
we wouldn't be here without the scientists and engineers who are working on this stuff.
absolutely. They're the ones making all of this possible.
They're pioneers, they're the trailblazers, pushing the boundaries of science and technology.
I couldn't have said it better myself.
And this isn't just about them, though. This quantum revolution, it's going to affect all of us.
Absolutely. As quantum computing becomes more common, it'll touch every part of our lives.
It feels like we're on the verge of something huge, right?
Yeah.
It's like this isn't just some niche technology for experts anymore.
It really isn't.
Quantum computing is becoming something we're all going to have to deal with.
I think so.
So what do we do? Just sit back and wait for it to happen?
No, not at all.
Okay.
Everyone should try to understand this technology,
Yeah.
learn about what it can do and what it might mean for us.
Okay, I get that. But for someone who isn't a scientist
Right.
or a programmer, what can they actually do?
Well, there's actually a lot you can do.
Yep.
You can start by just learning the basics.
Yeah.
There's a ton of stuff online, articles, videos, all sorts of things.
I love that. Just getting a basic understanding will be so helpful as this stuff becomes more and more common.
Absolutely. And don't be afraid to just be curious.
Yeah.
Ask questions, find out what interests you.
You know, this whole thing reminds me of when the internet was first becoming a thing.
Oh, yeah.
People were either scared of it
Yeah.
or they thought it was just a fad that would go away.
Right.
And now look at us, we can't live without it.
It's true. I think quantum computing could be just as big.
So for our listeners who are starting to get curious about this,
Yeah.
what's the most important thing to keep in mind?
Keep an open mind. Don't be afraid to question things, to wonder what if.
Yeah.
Sometimes the most amazing discoveries happen when you combine ideas that seem totally unrelated.
Like quantum physics and edge detection.
Exactly.
Who would have thought? This has been an incredible deep dive.
It has.
We started with blurry images and ended up talking about the future of, well, everything.
And we've only just scratched the surface.
Right.
The most exciting thing is that we don't know what we don't know yet.
Yeah.
What other amazing applications are out there waiting to be discovered?
That's a great question. If quantum computers can do this with images, what about other types of data?
Exactly.
What secrets of the universe are hidden in there, just waiting to be found?
I can't wait to find out.
Me too. This deep dive has really shown us how much potential quantum computing has.
It really has.
It's going to change the world as we know it.
for sure.
So to all our listeners out there, keep learning, keep exploring, and keep asking those big questions.
That's the key.
You never know, maybe you'll be the one to make the next big breakthrough.
The quantum world is waiting for you.
That's it for this deep dive. Thanks for joining us, and we'll see you next time.